Okay, now section 12.5 is optional, and if I have anything from this on the test, it will be extra credit. Okay, if I did, it will be extra credit. I spend like 10-15 minutes on this. Mathematical induction. So basically, mathematical induction is like having a stack of pens stacked next to each other, and if they're stable, the only way to push all of them is to push the first one. The first will push the second will push the third will push the fourth, and then all four. So it requires one from the first to the second, then the second to the third, and so on. That's what it's based on, mathematical induction. Okay, it says to prove a statement. By mathematical induction, like to make sure all the pens fall. That's what it means. Check if statement is true for n equals 1. You push the first pen to hit the second pen, and so on. That's what it is. If not, stop. So if the statement is not true, if you cannot push the first pen, then stop and say that statement you're trying to prove is not true. Statement is not true, and that's it. If yes, if you can push the first pen, if n is 1, it's true. Then if statement is true for n equals k, if the second pen will push the pen, the third pen will push the fourth pen. So if n equals k, it's any pen in the middle. We need to show it's true for n equals k plus 1. Basically, if we hit any of the middle ones, then it will hit the next one, k plus 1. That means all of them will be dropped. Here's an example. Okay, we know this from the sum of the first n term, but we're going to prove it using mathematical induction. 1 plus 2 plus 3 plus 4 plus n equals, remember, Sn, n times n plus a1 plus an over 2. We proved that. Okay. So to prove that, check if it's true for n equals 1. So for n equals 1, 1 equals 1 times 1 plus 1 over 2, which is 2 over 2, which is 1. So it's true. Then assume it's true. Assume you're hitting anyone in the middle. Assume true for n equals k, which means 1 plus 2 plus 3 plus 4 plus k, where k is somewhere less than n. Okay, it could be 5, could be 6. That equals k. So we know this is true. Okay, so this is true. Prove true for the next one, n equals k plus 1. So that's what we need to prove. Need to prove 1 plus 2 plus 3 plus 4 plus k plus the next one, k plus 1, equals k plus 1, k plus 1 plus 1, which is k plus 2 over 2. That's what we need to prove, and we have this true. So in order to go from here to there, we are going to add here k plus 1. Oh, wrong pen. We are going to add here k plus 1, and then we add there k plus 1. If we can, so this side equals this side. If this side equals that side, we're done. So let's check. So if we work on k plus 1 over 2 plus k plus 1, that's k squared plus k over 2 plus k plus 1 is actually 2 times k plus 1 over 2, which is k squared plus k plus 2k plus 2 over 2, which is k plus 2, k plus 1 over 2, which equals that. So we have showed that this is true. So it is true. Okay, that's by mathematical induction. All right, we can prove another one, and that's it. Number 8, page 819. Show that using mathematical induction, 1 times 3 plus 2 times 4 plus 3 times 5 plus n times n plus 2 equals n plus 1, 2n plus 7 over 6. So first we check for n equals 1. If n is 1, then it's 1 times 3. Does that equal 1? And that's what? 2, and that's 9 over 6. 18 over 6, 3 equal 3. So then we assume true for n equal k or k minus 1. It doesn't matter. I think I did k minus 1. If you do k minus 1, then you gotta go show k, which is the next one. If you do k, then you gotta do k plus 1. So we're assuming that 1 times 3 plus 2 times 4 plus 3 times 5 plus k times k plus 2 equals k plus 1, 2k plus 7 over 6. That's true. We need to show the next one, to show true for n equals k plus 1. So we need to show 1 times 3 plus 2 times 4 plus 3 times 5 plus k times k plus 2, and then the next one is k plus 1. K plus 1 plus 2 is k plus 3 equals, for n equals k plus 1, it's k plus 1 plus 2, 2k plus 2 plus 7, 2k plus 9 over 6. So all we need to do now, just like we did over there, we're going to add k plus 1, k plus 3 to both sides, and add k plus 1, k plus 3, and show that these two are equal. So here, if you take k plus 1, 2k plus 7 over 6, and add k plus 1, k plus 3, we need it to equal k plus 1, k plus 2, and then 2k plus 9. Okay, so then we need 6 and then 6. We can factor out k plus 1, and then it would be 2k squared plus 7k plus 6k plus 18 over 6. So that's 2k squared plus 13k plus 18 over 6, and that factors, so this guy factors into k plus 2, 2k plus 9 over 6, which equals that. Okay, which equals that, and that's it.